Hello, my dear students. A very good evening to all of you. I hope you are so well and be safe from this pandemic situation. This is Fluid Mechanics and Fluid Machines. Subject code is PCME 402. In previous class, I will discuss about Euler's equation of motion. Also learn about Bernoulli's equation and also discuss about its significance. As you know, this is very important section for your semester exam. Lots of questions are coming from this section in previous year. So today I will start the function of ORIFICEMETer and also the function of VENTURIMETer. Okay, let's start. Okay, let's discuss first about Bernoulli's equation for real fluid. The Bernoulli's equation was derived on the assumption that fluid is inviscid and therefore it is frictionless. But all the real fluids are viscous and hence offer resistance to flow. Okay, thus the Bernoulli's equation for real fluid between point 1 and 2 is given as u1 by rho g plus v1 square by 2g plus z1 equal to p2 by rho g plus p2 square by 2g plus z2 plus hl. Now what is hl? Where hl equal to loss of energy between point 1 and 2. Okay, this is hl, loss of energy between point 1 and 2. Okay, it can be write as this one. Okay, now next one is practical application of Bernoulli's equation. Here you can see uh, now Bernoulli's equation is applied in all problems of incompressible fluid flow where energy consideration are involved, but we shall consider its application to the following measuring device. Okay, number one is venturimeter. It can be written as venturimeter. Number now number two is two is orificemeter. Number three is Peter tube. Okay, these are the main section. Okay, now we can discuss about venturimeter. What is venturimeter actually? You know venturimeter? What is venturimeter? Venturimeter is a device for measuring the rate of flow of fluid going through a pipe. Okay. This is D1. Okay, you can see in picture. This is inlet section, and this is throat. Actually, throat. Okay, this is throat, and this is small h height. Okay, the main parts are short converging part. Number two is throat. Number three is ravaging part. Okay, let considering all the terms. Okay, first one is D1. What is du1?
কথা বলিস না রেকর্ডিং হচ্ছে।
Du1 equal to diameter at inlet or section 1. Okay, diameter at inlet at section 1. P1 equal to pressure at section 1, and next one is B1 velocity of fluid at section 1. Velocity at section 1. Here all the terms are in inlet portion, so this is can be written as 1. Next one is A means area at section 1. We know that area of cross sectional part equal to A equal to pi r into d1 d square, but in case there is inlet section, so this is pi r4 into d1 square. Okay. Now for section 2, that will be d2 p2 v2 into a2. Okay, our corresponding values at section 2. Okay, corresponding values at section 2. Now we are applying Bernoulli's equation at section 1 and 2. You know the Bernoulli's equation means pressure head plus velocity head plus bottom head equal constant, but here is for section 1 and 2 means this can be p1 v1 z1 or p2 v2 z2. So this will be p1 by rho g plus v1 square by 2g plus z1 equal to 2 by rho g plus v2 square by 2g plus z2. Okay, plus z2. As we know the pipe is horizontal, hence z1 equal to z2. Okay, and z1 equal to z2. So both z1 z2 z2 will be cancelled. To cancel in z1 z2, the equation will like this: p1 by rho g plus v1 square by 2g equal to p2 by rho g plus v2 square by 2g. Okay, after separating this will be come as p1 minus p2 by rho g. Okay, equal to v2 square by 2g minus v1 square by 2g. Okay, as we know, small h equal to v2 square by 2g minus v1 square by 2g. v2 square by 2g minus v1 square by 2g. So putting okay, now first we applying continuity equation. We know continuity equation is equal to for two sections is a1 v1 equal to a2 v2. So after separating v1 is look like a2 v2 by a1. Now this value of v1 is putting in that equation means h equal to v2 square y by 2g y minus 2g. So putting this value, the equation looks like h equal to v2 square by 2g minus in bracket in upper portion a2 into v2 by a1 whole to the power square by 2g. Okay, now can get small h equal to after calculation all the terms that will come as v2 square by 2g in bracket a1 square minus a2 square by a1 square. Okay, after separating this will become as v2 square equal to 2gh into a1 square by a1 square minus a2 square. Okay, so from here we easily calculated the value of only v2, so right portion will be square, so v2 equal to uh, a1 a1 by root over a1 square minus a2 square into root over a1 square minus a2 square into root 2 gh. Okay, so you can get the value of v2, but will be needed the value of discharge means q. So this will be q equal to, that for outlet section a2 into v2. Okay, a2 into v2, so a1 into a2 by root over a1 square minus a2 square into root 2 gh. Okay, so this is actually theoretical discharge, but we needed actual discharge means q act. So q actual discharge equal to cd into root over a1 to a1 to a2 by root over a1 square minus a2 square into root 2 gh. Okay, now uh, we know cd equal to the value of cd is always less than 1. So this is the very important equation for venturimeter, and q actual equal to cd into a into a2 by Victoria square into 2g. We try to memorize this equation. Okay, now will be next portion, that is value of h small h given by differential u2 manometer. Actually the small h equal to x in bracket sh minus so minus 1. But what is so and what is small x? So sh equal to specific gravity of the heavier liquid. So equal to specific gravity of the liquid flowing through pipe. Specific gravity of the liquid so or specific gravity of the liquid flowing through pipe. Specific gravity of the liquid flowing through pipe. Okay, and the last one is small x, that is difference of the heavier liquid in u2 column. Small x, that is the difference of heavier liquid in u2 column. Okay, small x difference of liquid in u2 column. So okay, 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 our next topic is orifice meter. Okay, at first you will be have some basic knowledge about, so I can give you some basic knowledge what is orifice meter actually, or what is the function of orifice meter. Now it is a device used for measuring the rate of flow of a fluid through a pipe. Mainly it is a cheaper device as compared to venturimeter. It also work on the same principle as that of venturimeter. Okay, no, so this is the figure of orifice meter, you can see. uh, okay, now I can describe. Okay, So you can see this one on section, that section is called pipe. Okay, it's pipe. And now this is the main section. This is orifice meter. Okay, or you can say this is orifice plate. Okay, the diameter of the pipe through it might vary from 0.4 to 0.8 times of the diameter. Okay, and now this lower section, this is differential manometer, which will be added to in orifice plate. Actually, you can see the direction of flow in figure, in which direction the liquid will be flow. Okay, so now we can discuss all the parameters. Let first one is P1. As you know, P1 is pressure at section 1, means inlet section, pressure at section 1. Okay, next one is V1. V1 equal to velocity at section 1 or inlet section. Anyway, next one is A1. This is area of pipe at the section 1. Okay, or inlet section, the area of inlet section you can say. Okay, now as comparing or as same as venturimeter, you can know this P2, V2, A2 are corresponding values at section 2. Okay, means pressure at section 2, velocity at section 2, or you can say area at section 2. Okay, corresponding values at section 2. Now as same as we will applying Bernoulli's equation in venturimeter, here also we will be applying Bernoulli's equation. Okay, now applying Bernoulli's equation at section 1, section 2, we get P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. So after simplifying this equation, we can get P1 by rho g, P1 by in bracket P1 by rho g plus Z1 minus P2 by rho g plus Z2 equal to V2 square by 2g minus V1 square by 2g. Okay, I think you can understand. And next is is this section, means P1 by rho g plus Z1 minus P2 by rho g plus Z2. This will be written as H. You know, H is differential head, means difference of the section. Okay, differential head. Now small h equal to, we know that small h equal to V2 square by 2g minus V1 square by 2g. Okay, after separating this, the equation looks like 2gh equal to V2 square minus V1 square. Now we can separate from V2 this equation. V2 equal to 2gh plus V1 square. Okay, okay, it is very easy. Now next is, we know cc. Now what is cc? What is cc? Cc means coefficient of contraction. Okay, now cc equal to, we know a2 by a0. Okay, after, so there is a2 equal to cc into a0. Now here we also applying continuity equation that we know for section 1 and 2. So will be a1 b1 v2 v2. So from this v1 equal to separating this is a0 cc into by a1 into v2. Okay, so v1 equal to a0 cc by A1 into V2. So putting this value in V2, okay, V2 is previous equation. So I can get V2 equal to root over, okay, 2gh plus a0 square into cc square into v2 square divided by a1 square, okay, divided by a1 square, okay. So now from this equation, v2 equal to okay, equal to root over 2gh. Simplifying all the terms, the equation looks like root 2gh minus divided by root over 1 minus a0 by a1 whole to the power square into cc square, okay, into cc square. Now we know the discharge q equal to v2 into a2. So we know a2 equal to a0 into cc, so in place of a2 we will write a0 into cc. Now v2 equal to looks like a0 into cc into root 2gh by root over 1 minus in bracket a0 by a1 square into cc square into cc square. This is international. The above equation, after simplifying, this will be look like cd equal to cc into in upper portion under root 1 minus a0 by a1 whole to the power square by lower portion 1 minus in bracket a0 by divided by a1 whole to the power square into cc square, okay, into cc square, and cc equal to cd in upper portion root over 1 minus a0 by a1 whole square into cc square. This will be under root, this total part is under root, also under root in lower portion 1 minus a0 by a1 whole to the power square, okay. So substituting this value of cc in previous equation, we get q equal to a0 into cd in, okay, this line, and in upper portion this will be 1 minus a0 by a1 whole square, and this is cc square in lower portion under root 1 minus a0 by a1 whole square into root over 2gh by in under root 1 minus a0 by a1 whole square into cc square, okay. So the final equation looks like q equal to cd into a0 a1 into a1 into root 2gh divided by root over a1 square minus a0 square, okay. This is the, so we know that cd equal to coefficient of discharge for, this is for orifice meter, okay. The coefficient of discharge of for orifice meter is much smaller than the for venturimeter. So this is q, this is very important equation, okay. So this cd means coefficient of discharge, as you know, as I tell you, coefficient of discharge. So this is very important for your exam. Okay. Okay, that's all for today. In next session I will discuss some numerical problem. I hope you can understand this session. Thanking you for listening this session. Okay, goodbye.